Okay, I'm going to skip through a couple of these examples here. The last one was pretty similar to the previous ones. So the example number 6 is where we start getting into some different denominators. So notice here we started off with x cubed plus 6x squared. So x cubed plus 6x squared, we want to factor that as much as possible. So we can factor out an x, and we'd have an x squared plus 6x. Actually, we could factor out as x squared, huh? Let's factor out an x squared. So we can factor out an x squared and have x plus 6 left over. Okay, so now our least common denominator is x squared and x plus 6. But this factors nicely, but it has an exponent. So that is where we have a repeated linear factor. So that's our type 2. And then notice they've already given us our decomposition here. So we know that we need to have these denominators, but the reason that they include the x and the x squared is because that is a repeated linear factor. And so we need to make sure and use every possible factor within that. So we're going to end up with x squared plus 45 is equal to a over x plus b over x squared plus c over x plus 6. So notice the difference here. We do not need to put a bx plus c above here because this is a repeated linear factor. It is not one of the quadratic factors that cannot be reduced. Okay, so that's the difference here. We also need to put in a placeholder, it looks like, on our left-hand side. So we need an x squared, x squared plus 0x plus 45. And that did have a denominator, x cubed plus 6x squared. So we are going to multiply both sides of this equation by its least common denominator. Okay, so the least common denominator, and I'm just going to use the factored form. Actually, just this, yeah, because we need to use that. So let's use the x squared, x plus 6. So what we factored up here, don't use these 3 because that's going to give you a different denominator. Okay, so be careful with that. So now I'm going to go ahead and multiply that all out. This is all going to cancel on the left-hand side, and we'll be left with x squared plus 0x plus 45. On the right-hand side, an x will factor with one of those x's, and we'll have a times x plus 6 plus b. Now the whole x squared is going to cancel, so we'll have b times x plus 6. And then for the c, the x plus 6's will cancel, and we'll have cx squared. Okay, go ahead and multiply through, get rid of all of our parentheses. I'm going to kind of do this all in one step. So x squared plus 6x times the a. So ax squared plus 6ax plus bx plus 6b plus cx squared. Now rearrange so that everything on the right-hand side is with like terms. And I'm also going to factor at the same time. So I can factor out that x squared, and I would have a plus c x squared plus 6a plus b times x plus 6b. Okay, so we have a 1x squared over here plus 0x plus 45. So we're going to have a system of equations with a plus c equals 1 from this coefficient and a plus c. Then 6a plus b must equal 0. 6a plus b must equal 0. And then for my constant term here, 6b must equal 45. I'm going to put that over here. So 6b must equal 45. So we can go ahead and solve that one right there, easy enough. So divide both sides by 6. And what are we going to get? 45 over 6 kind of running out of room there. So what will that be? 3, 15, 3, 15, 2. Okay, hold on a second. I gotta make sure I got that one right. Yeah, we're good. So 15 over 2 for B. And then if B is equal to 15 over 2, then we can come back down to this equation here and plug in our B. So now we have 6A plus 15 over 2B equals 0. So subtract 15 over 2 from both sides. We get 6A is equal to negative 15 over 2. And then divide both sides by 6 or multiply by 1/6. And we get negative 15 over 2 times 1/6. Then we can reduce here and here. 3 becomes 2 and negative 5. So negative 5/4 for A. And then A plus C equals 1. So negative 5/4 plus C is equal to 1, which we could write that as 4/4. Add 5/4 to both sides, and we get C equals 9/4. Again, this one I'm just going to set it up for you. On this one we've got 6x squared plus 15 over x cubed plus 2x squared plus 9x plus 18 is equal to, let's say, a equals f of x again. So a over x plus 2. Now that one is just a nice linear factor. But this one over here, you'll see that x squared plus 9 is a quadratic equation that cannot reduce. So for that one, we're going to have the bx plus c and have a linear factor in the numerator this time. And then x squared plus 9 in the denominator. Multiply both sides by least common denominator. I'm going to skip quite a few steps here. We'll have a x squared plus 9x plus, now we're going to have to FOIL here, so I'm going to go ahead and write that out. X plus 2. Now we need to put a middle term in over here. So 6x squared plus 0x plus 15. And then ax squared plus 9x plus bx squared plus 2bx plus cx plus 2c. Alright, now we can regroup everything and factor out. So I'm going to have a plus b for my x squared term. For my x term, I'm going to have 9. Is that right? Yeah. Where did the 9x come from? Ax squared plus 9a. Yeah. I think that looked right. Okay, so I multiplied that one to there. So ax squared plus 9a. Yeah, sorry about that. So 9a there and 9a there. That's better. Okay, glad I noticed that. So a plus b and then x squared and then 2b plus c x. And then for our constant, we are going to have 9a plus 2c. Okay, so we get a plus b equals 6, 2b plus c equals 0, and 9a plus 2c equals 5. So quite a system of equations there. You have 3 unknowns and 3 equations, so it is possible to solve all of that. I'm going to go ahead and pause it, and then I'll just give you the answer for that one to make sure you work through it properly. Okay, it's obviously getting too late at night, and I'm too distracted by other things here. So, forgot a 15, and forgot a 1 there. Okay, if you've got that 1 in there, then everything works out great, and you end up with A equals 3, B equals 3, and C equals negative 6. So you end up with 3 over x plus 2 plus 3x minus 6 over x squared plus 9. So f of x is equal to 3, and g of x is equal to 3x minus 6. Okay, and I think that is it for notes. I think if you follow through with all of those, I also have worked examples up as well. I think you should be able to make it through all of those examples, or all of your homework problems. Okay, I changed my mind. So on this one, they're just asking how many fraction terms are there in this partial fraction decomposition. They do not want you to solve, but for this one we would have, see all of these exponents on here. For this one, you can factor that one. That's a nice factor. So for that one, the numerators are all going to be constants. But for this one, we cannot factor this one. It does occur more than one time as well, but you cannot factor it either. So it has to have a linear numerator. So you're going to end up with a over x, and this only asks for the number, but I'm going to show you what they would all look like. A over x, b over 2x minus 5, so that's our first term out of a cubic term, plus c over 2x minus 5 squared, plus d over 2x minus 5 cubed, plus, now these ones are going to have a linear numerator, so ABCD EX plus F over, I not even gave myself enough room, x squared plus 2x plus 5, and then gx plus h over x squared plus 2x plus 5 squared. Now, luckily they don't ask us to do any more than that. They just want to know the number of partial fractions that you're going to have in there, and the answer is going to be 6 for this one. So 6 separate fractions.